So welcome back to the channel. Hope everyone's doing well. What we've got for you today is a review of another clamp meter, and this is the Infurider YF-570C. This retails on Amazon for somewhere between £35 to £50, depending on which store you get it from. As you can see, perhaps in the corner there of the box, it is another made in China unit. And they do make a few other clamps, if I can get that focused there. So that's the one I have, the box that's ticked there, 570C-APP. So as you see, it comes cardboard box there. Put them out of the way. Inside the cardboard box, you get the meter and a little carry case. You have a little carry handle up here for it, but there's no loop for a belt or anything like that. And there's no markings on it, no manufacturer's markings or anything, or form of branding. Inside there we have the meter itself. We have a temperature probe on this one. I'm not 100% sure if this is a K-type, as per the vast majority of thermocouples that you get. It doesn't say an awful lot on it. It is a bit of a, although obviously this is quite a solid build in comparison to a thermocouple that you usually get, but you can see perhaps down at the end there, I don't know how well you can see that, it's not really glued in very well, so it's a bit untidy. A cordy flex, I guess. But lead wise, you get a set of leads. These are undoubtedly PVC, I would say. There is no, oh, there's a cat rating on them. Beg your pardon, Cat 3 1000 volt, actually 20 amps. But there is no GS38 caps on them to cover the tips up. So quite how they get them to Cat 3, I do not know. Yeah, you get what you pay for, I guess. But those are in the kit. And we get a little 365 days warranty card in there, and tech support address for that as well. And then finally you get a little instruction sheet which has got a few bits and pieces on there. It's got access to, or I say it's got QR code to get you access to the software for this, because this has a Bluetooth module inside it, which we can hopefully play with a bit later. You've got all the specs down this side, and a few more instructions for its use on the opposite there, and that's pretty much it. Okay, so quick look at the instrument itself. This is a pretty basic clamp meter. Certainly doesn't have the functionality of some of the other ones that I reviewed previously. We've got a rubberized outer boot around this, just around this sort of like bottom half of it. The rest of this is all hardened plastic. Input wise, you've got the three inputs here, temperature positive, volts, ohms and frequency there, the common of course, and then the temperature negative is on this one here. I'm not sure whether the Cat 3 rating is for that or for these two here. I think it's just been misplaced slightly. However, there is no external verification of that Cat rating there. You've got the CE there, whether that's China export or whether that's a genuine European certificate, I do not know. So just have a quick deco battery wise. Single Phillips holding this in. It is threaded. It kind of is, it's just like a tight fit in there. It's not fully captivated, so it will come out. There is a brass insert in there, and we're actually on a PP3 9-volt battery for this one. Unusual and not my favourite choice for batteries for an instrument, but there you have it. Looking at more of the functionality, obviously we have the LCD down here. We'll turn him on. Fairly large digits on there. All the auxiliary functions are kind of very small up in the top of the screen there. We do have a light on it, which we hold in. And there we go, quite a nice light. Makes the screen very clear there. You have this button for the light is also a data hold, which I seem to have managed to have put it on for a single press, and press for greater than 2 seconds for the lights. Where we on a function that has multiple aspects to it, we have select there, that changes between AC DC for this particular function, or ohms, capacitance, diode, continuity, and that's all that one does, just for those 2 scales there, if I remember correctly. Where we have it as well, we have a range where we can change on here. We also have a relative function for zeroing out, more particularly when we're on resistance and capacitance and DC current. And then for the Hertz function, you can change between this one here for duty cycle or frequency there. That also works on the voltage as well. It gives you a frequency or duty cycle when you're actually on measuring mains voltages, or takes you back to AC voltage there. On current, it doesn't work on the current function though. And that is pretty much the basics of the instrument. A couple of things, as well as the PP3 battery there. The actual position of the selector switch is on a small little triangle that's embossed on the top there, but it's the same colour, so it is not the easiest thing to see. That could have been done with being made into a black, and then it'd be more obvious where it is. And the other thing that I have noticed as well with this, for the clamp function, this is a mighty tight clamp. It is a 40mm jaw capacity, which the other clamps have been doing has been 30mm, so it's slightly wider, and you can see, if I compare it to the Kaiwich unit here, you can see probably that way around is probably better. You can see there, hopefully, that it's much wider, and open him up there, you can see you've got a little bit more capacity within the jaws there than you have with a lot of the other clamps. But there's an example you can see there for the rotary function. You can see the arrow is clearly marked out via a different colour, so it's a bit more awkward to see on this clamp. Just going to try and measure how much force is required to open this clamp up. So I've done that one there, that's 5.35 kilograms it's come out with that one there. Let's try the Kaiwich and just see what the difference is there. And you see 2.65 kilos required for that one. So you see this one here requires double the amount of force to operate this clamp, and it really is noticeable in comparison to a lot of the other clamps that I've utilised. Okay, let's chuck all that out the way, and let's do some voltage measurements. Okay, zoomed in a little bit there. We'll do some DC voltage measurements, is what it's set up for at this moment in time. I'll also stick the table up. So there's our first measurement there, that's 6 volts DC there. You can see it's on 5.99. Let's move up to 10 volts. I put the measurements up that I made. I just did 4 checkpoints up to 300 volts, which is easy enough for this test set. And you can see that they are actually all in tolerance. There's the 300 volts there, 299.5. So no problems there. Let's just take it to AC. We'll change our test set to 50 Hertz. And didn't like that, switched itself off. Back on again, so there's 300 volts AC at 50 Hertz. And again, I'll put the table up for measurements I made at AC volts as well. And you can see those two are all within complete spec. no problems at all. And if I said before, if I do the, you can pick up frequency there, 49.99. Let's just see if we can, 60 hertz, 59.99. So no problems there. Let's go 200 hertz is another popular one for me. 200 hertz, 199 there, and you can go to duty. We've got 50% there, and then we can go back to AC voltage measurement there as well. So yeah, voltage reading wise, no problems found whatsoever. So we're on our resistance decade box. Resistance wise, you can see we do have the relative function, but you can see it's reading 0 anyway on my decade box, so we've got no problems there. There's my 1 ohm reading there. Again, I can put the table up as well, and you'll see there's no problems with any of the resistance measurements that I made. Let's go flip them off, and we'll go 1K there. Let's flip him up to 11K. So it's not the fastest, but it's reasonably accurate. Not too much of an issue really, as you want 100K there. Up to 10 mega ohms. Hopefully you can see it now, yeah. And then there's our maxed out 40 mega ohms there. As I say, all within tolerance, so no great problems there whatsoever. Okay, so software demo time. Software's downloaded onto my iPad here. And we are set up on a resistance decade just to give some data. We've got 100 ohms reading on the screen. Okay, so it appears that the Bluetooth is permanently on the clamp meter. You can see it from the RS232 that is displayed upon the screen. I've not found a way to turn it off. So you merely hit the start button on the display there, and then it will start recording for you. And you can see the reading has been transferred, 100 ohms on the screen. You can see the dial there has moved over. Let's go to 1100 ohms, 1.1K. There you go. Let's go up to 10K, 11, so it's 11K, 11.1K there. Let's knock the other two off. Back down to 10K. Let's go 1 meg. Overload, see it ranges, 1 meg. So there you see it there. Once you've collected all your data, you can hit the stop button, and then you can look at the data itself, and it gives you that. You've also got the option to save it and export it. If you prefer, you can have it in a graph format. It's quite difficult to see. It's a red line along there. Yeah, that's not really worked out very well, has it? Let's start it again, go graph now. Yeah, not sure about the graph, that's not really displaying much, is it? Okay, there you go. Yeah, not sure, it does, it's such a short range of data there. Don't know whether you can change that or not. So you can change the sampling rate there, 60 per minute it's on at the moment. Every second, I guess, there. You can't really, yeah. Graph doesn't seem to be working too well as far as I'm concerned. The data there is quite good. Obviously got a good data table there, but the graph function doesn't seem that good. Now obviously you've got the display there if you prefer that. And that's the software, fairly limiting I guess, but probably good enough just to record some readings and get the data sent over for manipulation in a computer. Capacitance, so select button, actually takes me to diode. I'll cycle around and we'll go to capacitance first. I'll stick the table up for this initially. You will see down at the bottom end the 1 nanofarad. I did struggle to get that measurement in tolerance. With all the others there was no issue whatsoever. You see we're on 0.28 residual there. Hit the rel button and I can get it down to 0. If I go for my 1 nanofarad now, and you can see I'm actually on 1.26, so a little bit out of tolerance with that. I got up to 2, 2.25, a little bit out of tolerance but getting closer. 3, and you see it starts to dial in now. We're at 5. Let's flip them around, take him to 10, and we should be back within tolerance there. So from here on in, all the readings were within tolerance. Let's go up to the 100 nanofarads there. We've got 98.7, 1 microfarad, 0.991, 10 is there. Just slightly out of picture, sorry about that. Hopefully there you can see it there. We've got 10.10. And we say we can go up to 100, so there's a good old classic 47 there, which is 48.04 on that, and then just winding up to 92. You see it takes it a little while to get there. It does take a little bit to settle as well. And there you go, 95.4, it's picked up with that one. So yeah, bit slow, bit of a shortened range, but it is usable. To resistance, so we are on diode test now, so we'll get our little diode boards. No beep at all when it shorts, but so look, see what we get. That's our stub diodes there. This one will be open circuit. Flip him. And we get a reading there. This will be our Zener diode here. 628, and this is our shock key, which is much lower. 20, that's about right. This is our high voltage diode, which should be. Ooh, we didn't get a reading. Okay. So we don't get a reading on our high voltage diode. Sure we are connected. That's interesting, isn't it? Let's just have a look at our. We don't get a reading on our LED. It doesn't light it, and you can't see a voltage either. Let's just triple over to our LED board here, our red LED, green LED, blue LED, white LED. Ooh. Well, there you can see our diode test voltage is 1.505, which is extremely low for a diode test. I suspect that's what's given, because 1.8 volts for the red LED, so that's just not going to work at all, is it? Wow, not for use on LEDs. There you go. Let's just see what the other functions are. Continuity, we are 0.4 volts. Capacitance we won't like, and normal resistance is also 0.4. Wow, that is low, isn't it? 0.23 volts for your resistance measurements. Wow, it's not looking good, is it? Let's go to, I don't know whether I dare do this actually. Done diode, we're in continuity. I suppose we're going to have to, aren't we? Well, that just dipped the light as well. Wow. Let's just turn the light off. I mean, yes. Yeah, okay. I mean, it does kind of squawk at you a little bit, doesn't it? Oh, dear me. We'll go for the gold plated. They do plug in easier. Let's just see. Yeah, still a little bit scratchy, but it's fast. You give it that. It is certainly fast. Let's see how loud she is, shall we? So there you see 76.4 decibels there. Okay, so we'll start out with some current measurements. Let's put them into, we're on 10 amps DC. We didn't zero it first, beg your pardon. That's zeroed there. So we are on the 200 amp DC range there, putting in 10 amps, and we are getting 10.2. Let's go down to the top of the clamp, 10.2, bottom of the clamp, 10, 10.1, side to side. So pretty stable, not bad at all there, really, in that respect. It does actually say on the pamphlet that comes, or the sheet of paper that comes with the instrument, that it is really designed for measuring 10 amps and above in terms of using the current clamp there. So split ranges for DC amps there. For the AC you have the same 400 amp and 1000 amp ranges on the same rotary selector position, and you can change range. It will do auto, or we can change it manually through the range button there. Change the position. Let's put in 10 amps AC there, 50 hertz. See what we get. 9.9 amps, 10 amps. So I'll put the little table up that I made for both AC and DC. All the measurements were pretty much within spec. Even below 10 amps, all the readings were within spec. But if you go and take a look at the actual accuracy there, that 12 digits that you add on to the end of it, the accuracy is so wide you really can't fail to be in spec, to be honest with you. So I'll just knock this table out of the way and I'll stick the larger clamp table in. Okay, we're set up for some high DC amps, reading 300 amps. I think I'm actually starting to struggle with battery on this now, because if I go to put the light on, we're on 300 amps there. If I go to 10 amps there, should be 500. We're on data hold. And you can see I can't actually get up to 500 amps now. I go back down to 6 amps, which should be 300 amps on this. I've dropped now to 218. Let's knock him all the way off. Turn him back on again, and I'm back up to 300 amps. With no light on, let's go up to 500 amps. Should actually over range on that one. We've got 508, so we're okay on that one there. So it looks like, I'll drop the cover out and measure the battery voltage. It looks like that's what's going on this already, and I know it's not the best of batteries, but what are we on here? So that's AC 500 amps, and we're on 501, so it's good and accurate in that respect. Taken to, there's our 950 amps, and we are 953. So yeah, it's going. It does function, but that battery is seriously limiting to it. Let's see what we get. Oh, 8.3. It's not the lowest then. It obviously has dropped off some, but not down to like 7.5 volts yet. But obviously it's still already affecting, or starting to affect, the performance of the meter. Okay, so we've got our power supply set up. We're putting in 9 volts. We're drawing 1.8 milliamps. We're just on the diode function there. Let's just turn the light on. 40 milliamps for the light going in. That is quite a lot, isn't it, really? If you consider that's just a PP3 that's in there doing that. Let's just see what we go down to. So 8 volts. We've got no battery alarm. Let's just make sure hold doesn't hurt it. 7 volts. So we've dipped the backlight a little bit on 7 volts. 6 volts. We've dipped it some more. 5 volts. Dipped it some more. Still no battery symbol. Halfway. 4.5 volts. Still no battery symbol. Oh my word. 4. So the light's gone off at 4 volts, but we've still got no battery symbol. Well, we've got 3 volts, so battery symbol has now come up in the corner. We're looking in this bottom corner here, see there's no battery symbol light on at the moment. Let's just go 3.5 actually, not 35. That would not be good. So at 3.5 volts we've got our battery symbol come up there in the corner. Our light has stopped working. If we go back up to 9 volts, the light comes back on, so it remembers the light should have been on, but it just kills it off itself. So 3.5 volts. My other battery was down to 8 volts. I was getting bad readings, so I shuddered to think what kind of reading you would get. Even, I mean, at 6 volts you saw this backlight does dim appreciably. So I'd perhaps give you a bit of an indicator, but that's pretty dire indeed. I can't say that I could recommend you buy an Infurider current clamp. I think that's one to stay well and truly clear of. So anyway, this one's gone on for long enough. I'll have to do a serious amount of editing to try and cut this back, I would say. That'll be it for this video. Thanks for watching. I hope you found it useful, and I'll see you again in the next one.